Again, it's a redskin.
What is going on, guys? Welcome back. In today's video, we're going to learn how to use scikit-learn's pipelines to make your machine learning processing more professional. So let us get right into it. Alright, now for today's video, I'm going to use a Jupyter notebook in order to explain everything because I think it's just more convenient to do so. You can still follow along in PyCharm, in the idle, in VS Code, whatever you want to use. But for me as a tutorial maker, a Jupyter notebook is just more convenient when working with data science, machine learning stuff because I can run individual cells, I can change individual parts and rerun them instead of just running the whole block of code every time I do something. So I'm going to use a Jupyter notebook. And in order to explain to you what pipelines are, how to use them, and why you should use them, we're going to look at a very simple example today. And for this, we're going to need the usual Python data science stack, like pandas, numpy, matplotlib maybe. I mean, we're not going to use matplotlib, but scikit-learn is important, of course, because those pipelines come from scikit-learn. And we're going to start with a very basic example. We're going to import pandas as PD. And we're going to create some artificial data. This data is going to start as a dictionary. We're going to say we have a name. So this is the column name. And then we have here Anna, Bob, Charlie, Diana, and Eric, whatever. Then the age is going to be 20, 34, 23, 78 and 33. Then the gender is gonna be F for female, M for male, so F, M, M, F, M. And then what we also have is a job, or what they have is a job. And let's say we have 3 jobs or 4 jobs to choose from. Let's say we have a programmer, we have a worker, writer. We have a cook, we have another programmer, and we have, I don't know, let's say teacher or something. Now, this is some sample data that we're going to use to explain pipelines. And when you get data from the real world, sometimes data is going to be missing. For example, we might not have this data, we might have none here, because this age is non-existent, so we need to find a solution for that. Now, first of all, let's go ahead and turn this into a data frame. df is going to be pandas data frame based on the data, and then we can look at the data frame. So this is a very small data set. It's artificial, it's not real. You can also do everything we learned today on real data sets. In fact, I have a tutorial on how to predict Titanic survivors using the Titanic dataset, and there we use actually pipelines and a lot of pre-processing. So if you want to have a practical example, you might want to look at that video. Today we're going to talk about the basics, and this is what a small dataset looks like. For example, we have missing values, we have values that we cannot feed into a neural network or into a k-neighbors classification, right? We cannot just go ahead and say programmer is something that we feed into the neural network. I mean, we can do it character by character as ASCII codes, but that's not what we want to do. Those are categories, and those are also categories. We have a binary value here, MF, so either male or female. We have missing values, and we have a value that is irrelevant probably for the prediction of something. Now, here we don't have anything to predict because we're not going to do an actual machine learning project. I want to explain the pre-processing part with a pipeline. But if we have like another feature here like salary or happiness or whatever, we might use those values, but the name is not going to be very relevant. So for today's pre-processing, the job is going to be the following. I'm going to define this here as markdown. We're going to say the pre-processing pipeline will be the following. First, we want to drop the irrelevant name feature. So drop name feature. Then what we want to do is we want to impute the ages, basically meaning that we want to do something with the ages. Now, we can just drop this line because we don't know the age. We can just ignore it. Or we can impute it with the mean or with another strategy. We're going to impute it here. So impute ages. Then we're going to turn gender into binary / numeric. So 0, 1. And then we're going to turn or one hot encode the jobs. One hot encoding basically means that we take categories, and instead of setting numbers like 1, 2, 3 or something, we create a new column for each job. So in this case, we would have a column programmer, writer, cook, teacher, and the value is either 0 or 1. Why is that more reasonable than labeling them with numbers and coding them with 1, 2, 3, and 4? Because 1, 2, 3, 4 will be interpreted by many models as proximity. So 1 and 2 are closer than 1 and 4. And in this case, it doesn't make sense. If programmer and cook have 1 and 2 and teacher has 4, the programmer isn't closer to the cook on a numerical scale than to the teacher. It is basically a category and not something like cold, medium, warm, hot, or something. There it would make sense to use numbers. In this case, it doesn't make sense, so we create separate columns here. So this is the pre-processing pipeline. This is what we want to do, and usually what you do is you do it by hand, right? If you don't use pipelines. So what you do, for example, is you say from scikit-learn .impute. You want to import a simple imputer. Come on, auto completion. There you go. Simple imputer. And from scikit-learn .preprocessing, you want to import the one hot encoder, and then you start. You drop the name feature. You do it yourself every time. So you basically say, okay, df equals df drop. You want to drop the column name on the axis 1. There you go. We dropped the name feature. Now I can print this here. You can see we don't have the name anymore. Now, of course, I cannot run this another time because then it's going to say there is no column name. So we have to run everything here actually in order to make this happen. Then the next one was impute the ages. Impute the ages is quite simple. We create an imputer, simple imputer. The strategy is going to be the mean strategy. So basically taking the mean of the other ages to basically ignore it on a larger scale here to get like the center value. It doesn't make sense every time. In this case, it might make sense, might not, depending on how important the age is for the prediction. And then we're going to say df age is essentially just imputer.fit transform data frame age, like that. Now I need to run this again because I deleted the name. And now if we look at the data frame, we have the age imputed. So before we had here a nan, and now we have a 27.5 because that's the mean. So this is imputed now. Next one was turn gender into a numeric feature. So numeric gender. And for that, we define a dictionary, which basically says, okay, M will be translated to 0, F will be translated to 1. And then the gender, actually we can do it like that to be consistent here, is going to be, and then list comprehension, gender dictionary, G for G in df gender. Now, of course, I need to rerun this. There you go. And now we have zeros and ones here instead of M and F. And last but not least, one hot encode the jobs. This is going to be not really complicated, but we're going to need a couple of more lines of code. So we're going to say, first of all, the encoder is going to be the one hot encoder. And then we're going to say, okay, the matrix that we want to use here is going to be encoder fit transform. I'm not even sure if that's the best way to do it. This is just how I did it in the Titanic tutorial, for example. Maybe there's a more clean way to do it, but what I do is I create a matrix by taking the jobs and then turning it to array, and then I basically take this matrix, put it into the data frame, and then add the columns manually by saying column names equals programmer. By the way, this only makes sense, of course, if we're not going to add more categories. So in this case, it might not make a lot of sense because the next job might be construction worker, right? And then we don't have the category and we mess things up. So job may not be the best example. We're going to stick with it here for the tutorial, but maybe something like role in a school, for example. If we have teachers or staff in school, we have someone who cleans, someone who teaches, someone who is the what do you call it, principal or something of the school. So that would make more sense because we don't add new roles there. In this case, we can always add new jobs, but since we're doing one hot encoding, we're going to stick with the jobs that we have here. Programmer, what was the other one? Writer, cook, and teacher. Those are the column names. And now what we do is we say for I in range length matrix T. And by the way, this is all just an example. You can work with real data sets. You can do your own pre-processing. So the focus is not on what we're doing right now. This is just the example. We're going to talk about pipelines. This is the most important focus here. So column names, I equals matrix dot ti. And then last but not least, we drop so df equals, we're going to drop the drops column because we now have it encoded. Axis equals 1. Now we need to run this again. And then we should be able to actually have the pre-processed data frame if it is also printed. There you go. And this is what we want to end up with. Now the problem is that if I go ahead now and I copy this here, and let's say those are not the same values here, but I have different values. So it's something like, let's continue with F. We have Fiona, Gerald, EFG, H, I don't know, Hans, which is a German name. I for, I don't know, a name with I. What is Isabella? J for Jacob. There you go. And then we have like another non-value, and then we have here FMM, again FM. Okay, there you go. And then we have different jobs like writer, programmer, and teacher. If we have this data now and want to do the same thing, we want to get it in that format, we would have to repeat that code. And of course you could say, okay, just put it in a function. And yes, you can do that. You can just make a function that does that. But it's more professional to use pipelines because then we have one element passing to the next element. So one part of the pipeline feeds its output into the next pipeline component, and then this component feeds its output to the next one, and so on. So we can either run the full code or we can use pipelines, which is what we're going to do. And for that, we're just going to ignore this down here. We're going to use that in the end to show how pipelines work. We're going to start by defining estimators, because in a pipeline, we have estimators. An estimator is something that has the functions fit, transform, fit, transform. So essentially, a classifier is an estimator. So when I say k nearest neighbors classifier, I can fit it, I can transform, I can fit transform, I can also predict, and so on. And in a pipeline, we have estimators. In order to create an estimator, we need to extend from the base estimator class. We need to create a new class, and we need to have the functions fit and transform. So we're going to say from scikit-learn.base, we're going to import the base estimator and transformer mixin. Transformer mixin basically just means that when we define fit and transform, it's automatically going to create fit transform. We don't have to specify it manually. And we're going to now create a class. The first thing we did was drop name feature. Now, let's, just for the sake of demonstration, here we're going to call this class name dropper just to see how it works. We extend from base estimator. We have transformer mixin here as well as the parent class. And now we just define the functions fit. Fit takes self, X, and Y, which is none by default, as parameters. And all we need to do here is return self. Nothing fancy. We're not going to use fit here. We're just going to return self, just so we have it defined. And the whole logic is going to be in the transform function. And the transform function takes self and X as an input here. And in this case, all we want to do is we want to say, okay, instead of returning X, and X in this case, keep in mind, is a data frame. Usually these estimators take NumPy arrays when you use them from scikit-learn. Ours here takes pandas data frames. So what we can do here is we can treat X as the data frame. X is essentially the same thing as df here. So we just return x.drop, and we drop the name column axis equals 1. So this already is an estimator that we can use. And I think I can show you here how it works. So let's actually go ahead and turn this into df2. df2 is going to be pd data frame data. like that. And now df2 looks like that. And what I can do now is I can say dropper equals name dropper. And I can say dropper.fit transform df2. And now you can already see that the name is gone. So this is what the fit transform did. And we're going to do now different estimators for the different purposes. We're going to have an estimator for, what was it? Imputing the ages. We're going to have one for making the gender numeric and one for one-hot encoding the jobs. And the next thing that we're going to do here is going to be the age imputer. Age imputer is going to also be a base estimator, transform a mix-in. Basically, we can copy this here. There you go. Fit function stays the same. And here in the transform function, what we do is what we did above. We say imputer equals simple imputer. Strategy is going to be mean. And then imputer. Actually, how did we do that? We said df, in this case, x, not df. H equals imputer dot fit transform df, and not df, sorry, x, and here we set h in 2 square brackets like that. Now you might say, can we not use imputer directly as part of the pipeline, since it is already an estimator, since it has already the fit transform function? We can do it, but imputer works with arrays, like not with data frames, and because of that we don't do that here. We have one layer of abstraction above that, and here we just return x as a result. And then the next one is the feature encoder. We're going to combine the rest into one estimator, and basically you can copy this again here, and we can now actually use the logic from above. So let's just copy this, delete that, paste this here, and now this stays the same. Now everywhere we have df, obviously we're going to change it to x because we're not working with df but with x. So here again, we change f and m to 1 and 0. And here we basically just do one hot encoding. Again, change it to x here. Column names are the same. Here we change this to x. We change this to x. And instead of assigning it to df, we just return it. So again, this feature encoder takes the data frame. We change the gender column to 0s and 1s. We encode the job to 0 and 1 features, to binary features, and then we drop the job column, and that's basically it. Now what we can do here manually is, since we have the data frame 2, let me just show it again, df2, this is what it looks like. We can go ahead now and say, okay, create a name dropper. So let's say dropper equals name dropper. Then the second one was imp equals h imputer, and then enc is going to be the feature encoder. And now what we can do is we can say just dropper dot fit transform df2, and we get that. Now I can feed that into the imputer dot fit transform function to build on top of that result. Now you can see that we imputed the age, and then I can say enc dot fit transform based on that result, and then it results in that. So this works, but this is manually, and now we can use pipelines to make this even more convenient by saying from scikit-learn dot pipeline import pipeline, and then you're gonna say pipe, for example, equals pipeline, and here we pass a list of tuples, and the first one we always have to specify as the first element in the tuple a name. So for example, dropper, doesn't really matter what you call it, and then the actual thing, name dropper. And of course, if you have hyperparameters that you can pass here in your model, if they're in your estimators, if they're more complex, you can do that. In our case, we have very simple estimators here. Then we have imputer, and this is going to be the h imputer. And then we have encoder, which is going to be the feature encoder. So this is the pipeline now. One estimator feeds the result into the next one, and then the pipeline takes some input and outputs the final result. So again, if we go ahead and we print df2, this is what it looks like. And if I now go ahead and I say pipe fit transform df2, you can see that we immediately get the result. So we just have to use that pipeline, this pre-processing pipeline. And this makes a lot of sense if we use it over and over again. Of course, if you just have to do it once, it doesn't make a sense to use a pipeline for it. Just do the steps and you're done. However, if you have to do it over and over again, because you do it first with the training data, then with the validation data, then with the testing data, and then in the future you might get new data sets in a regular time interval, and then you want to do it all the time. You don't want to do the steps all the time. A function is not professional. You just use a pipeline. You have one full piece of pre-processing pipeline that you just feed some data in, and on the other side you get the completely pre-processed data set for the neural network. So you just take the raw data, feed it into the pipeline, you get the pre-processed data out on the other side, and you feed it directly into the neural network or whatever you want to use. And this is how you use professional pipelines from scikit-learn in Python. So that's it for today's video. I hope you enjoyed and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.